How do you go about proving this? Okay, I think I mentioned before, essentially what you want to use is the index laws. Okay, I will use some of the earlier laws as well, so that's why they're in that order, but I'm just going to jump straight in here because it's the one that I used in my previous proof, okay, or previous question. So what do? I'm going to need to introduce some new language here, right? So for instance, these two here, I want to translate these from log equations into index equations, because then I can use the index law that I know, right? So for instance, let's say let log base a of x. Let's let that equal to one number, and let's let log base a of y equal another number. Okay? Now I'm going to rewrite both of these in index form so that I can use the index laws that I know. Can you see, by the way, even though this has nothing to do with induction, the logic is kind of similar, because I'm trying to rewrite things in such a way that I can use the laws I know. Except in induction, it was just using the assumption that I know, right? So okay, let's do this. If I rewrite this in index form, I start with the base. Okay, so the base of the log is the same as the base of the thing that's being raised to a power. Okay. Here's where things swap sides. Okay, so m is the power, and x is what's on the other side. And of course, this is exactly the same, but for the other letters. Okay. So if I call this 1 and call this 2. How am I going to start moving towards what I'm required to prove? A few different ways. I'm going to go for the right-hand side, because what I've got here written in index form is very easy to turn into the right-hand side. Right? So if I say 1 divided by 2, okay, I'm going to get x on y, right? On the right-hand side, that is. So I've got x over y over there. And what do I have over here? I've got a to the m on a to the n. Simple so far. Okay. Now, on the left-hand side, I can do some stuff with my index laws, right? Can you see? This is why I bothered to rewrite it in this way. I already know it's established that if I'm dividing indices, right? For instance, if you had 2 to the power of 5 divided by 2 squared, right? That would be 2 cubed, because 32 divided by 4 is 8. Is that following? Okay. So therefore, I can write that as a to the power of m minus n. And the right-hand side hasn't changed. Okay. Now at this point, I've done my index law part. That's a little bit like using the assumption, because I'm assuming the index laws. Okay. Now I need to reintroduce the logs. Okay. So because I got rid of them here, I got to bring them back. Right. So I'm going to take the left-hand side and the right-hand side, and I'm going to take the log of both sides. Okay. And since I'm dealing in base A, I'll take log base A of the whole thing. Right, so I've got a to the power of m minus n. Yep, okay. And log base a of x on y. Okay. So here, again, it depends on what order you choose to prove your things in, right? I'm going to take here, m minus n, that's the power of the argument, right? Like so. Okay. So I'm going to bring that out and be the coefficient. So I've got my m minus n. Here. See, I'm almost there, if you remember what m and n actually are. And then what I'm left with is log base a of a. Can you see how the proofs all lean on each other, right? And of course the right-hand side is actually already in the state that I want it to be. Log base a of a is, what power do I have to raise a to get a, right? Which is just 1. And m minus n is these original terms here, right? So I'm actually done at this point. Log base a of x minus log base a of y, which is equal to, I already have the right-hand side as I wanted. Okay, so that's what a proof looks like. To be honest, I think the hardest part is starting it, because you have to know what you're going to prove and then introduce some stuff that will get you there. I think the rest of it's actually not that hard once you've set it up.